Let's read the question. Show that 4 common tangents can be drawn for the circles given by x square plus y square minus 14x plus 6y plus 33 equal to 0, x square plus y square plus 30x minus 2y plus 1 equal to 0, and find the internal and external center of similitudes. So here they are asking that there are two circles. For these two circles, there is internal and external similitude that we have to find out. So even they are saying there are 4 common tangents for both of these two circles. So if at all we have to understand by the figure. So this is an approximate figure for this particular question. Once we solve, we'll be getting the exact figure. So now here this is first circle and this is the second circle. For both of the circle, we are getting a tangent. See here, this is tangent number 1 and this is tangent number 2. So these both tangents were meeting over here internally. Okay, and this is tangent number 3 and this is tangent number 4. These both are touching externally at this particular point. So once we solve, we'll be getting this more clearly. So however, this is just an approximate figure. So this is the first circle and this is the second circle. Alright, for them we got 4 tangents. So this is what they are asking us to find out, that the 2 points, this is the meeting point of the common tangents and this is other meeting point of the common tangents. These particular points we have to find out. So by then we'll be getting the 4 tangents also. So let's try to solve this further. So let's go forward. So I'll write the given first. Given equations of circles are, so I'll just represent these particular equations with s and s dash. So for circle I'm writing x square plus y square minus 14x plus 6y plus 33 equal to 0. So this is the first circle. Let's take the second circle also. I'll just represent it with s dash. So second circle is x square plus y square plus 30x minus 2y plus 1 equal to 0. So these are the two given circles. So for these given two circles, we'll find out the radius and we'll also find out the center for the circles. So I'll take the first circle, that is s. So that is x square plus y square minus 14x plus 6y plus 33 equal to 0. So this particular equation I'll equate with the general equation of the circle. So the general equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. So when I equate with the general equation, if I have to get the center of the circle, so we'll just compare with minus g comma minus f. So for this, I'm getting the center as, we can say this is a first center, that is I'm getting this is 7 comma minus 3. Alright. In the same way, even I'll find out the radius of the circle. To find the radius, we have the formula, that is for radius 1 equal to under root f square plus g square minus c. Alright. So let's submit these values. F is 7 we got and g is minus 3, and when it comes to c, that is 33. So let's solve this further. So this is 7 square is 49 and this is 3 square in the sense 9. This is minus 33. So this will be getting, when we add 49 plus 9, we are getting the value as 58. Okay, and minus 33. So when we subtract 58 minus 33, we are getting the value as 25. So root 25 is how much? It was 1. It was just a 5 as the value we are getting for the first radius. So now we'll just take the second circle and we'll find out the center and also the radius. Alright. The second circle we have taken as x dash. So I can write x square plus y square plus 30x minus 2y plus 1 equal to 0 is the second circle. So for this circle, again I'll represent with the general equation of the circle, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. So now for getting the center of the circle, I'll just take minus g comma minus f, where the center to the second circle center we are getting, once we compare the general equation and center, which is minus g comma minus f, so we are getting the center as minus 15 comma 1. So this is the second center we are getting. So let's find out the radius, that is the second radius of the second circle, that is f square plus g square minus c. So here we'll just submit the f value, that is minus 15 whole square, and this is plus 1 whole square minus 1. So let's solve this further. So I'll be getting this as, so when 15 square, what is the value of 15 square? 15 square is 225. So this is plus 1 minus 1 will get cancelled. So root of 225 is nothing but 15. So first radius we got it as 5, alright, and the second radius we got it as 15, alright, and the first center we got it as 7 comma minus 3, and the second center we got it as minus 15 comma 1. So by using these particular values, 2 of the centers and 2 of the radius, we can find out internal center of similitude and also external center of similitude, both of them. So first we'll just try to find out internal center of similitude. Okay, so let's do that. So before going further, we'll find out whether the two circles were touching or no. For that, I'll just take two centers and I'll find out the distance between two centers of the circle. For suppose if I have to show if this is the first circle, alright, and this is the second circle. So I'm just trying to find out the distance between this center 1 and center 2. This distance I'm just trying to find out. Alright, so let's do this forward. So I can write here distance between two centers. So that is center 1, center 2 is, so I'll use the distance between 2 points formula. For that I can write here the distance between, so first point I can take it as x1 y1, and the second point is of course that is x2 y2 is, so what is the formula we have to use here? That is, I'll write here C1 C2 equal to x2 minus x1 whole square plus y2 minus y1 whole square. Of course there is under root. So when we see the centers and the radius, we'll just write over here. So the center, C1 center, it was 7 comma minus 3, and C2 center, that is minus 15 comma 1. Okay, so this is x1 y1, this is x2 y2. So let's submit these centers in the formula. So here I can write the x2 is how much? It was minus 15, and x1 it was 7, so minus 15 minus 7 whole square, plus y2 is 1 and y1 is minus 3, so this is whole square. So let's solve this further. So this is minus 15 minus 7, we are getting this as minus 22 whole square, and this is plus 1, minus into minus, it is plus, so 1 plus 3, which is 4, so this is 4 whole square. So if we further have to write this, so this we have to write it as 22 whole square, we will be getting that as 484, and 4 square it is 16. Alright, so 484 plus 16 in the sense we will be getting the value as 500, that was root 500. Alright, so this is the value which we are getting, that as root 500, whereas if we have to see this, the centers, the distance between two of the centers, we are getting that as root 500. But even we'll even find out the sum of the two radiuses. So I can write here also r1 plus r2. The first radius we got it as 5, and the second radius we got it as 15. So first radius how much? That is 5. The second radius we got 15, so the total sum we were getting it as 20. But if we just see the root 500, if we have to find out, 10 root 5 we are getting. If we further solve it, we'll be getting this almost like 22.3 something, we'll get approximate value. So in such case, here the distance between center 1 center 2 is greater when we see the sum of the two radiuses, which means that both of the circles were not at all touching. So we can write here, therefore C1 C2 is greater than R1 plus R2. So here we can say two circles do not touch each other. Alright, so I can write here, we'll just find out the common tangents here. So I can write here, the given two circles have 4 common tangent. Alright, so first we'll find out the internal center of similitude. So I can write here, internal center of similitude. So that is divides what? Center 1, that is 7 comma minus 3, and the center 2 we got minus 15 comma 1. So internally they are in the ratio, that is R1 is to R2. Okay, so this I'll be writing internal center of similitude, which we can write the point, we're just taking it as P. So the formula to find out internal center of similitude, that is R1 x2 plus R2 x1 by R1 plus R2, and this is R1 y2 plus R2 y1 by R1 plus R2. Alright, so let's submit these values. Of course, the radius, first radius it was 5 and the second radius it is 15. So let's submit these values and we'll see what do we get here. Alright, so R1 is 5 and x2 it is minus 15, whereas the R2 is 15 and the x1 is 7, whole by 5 plus 15. And when it comes to this, R1 is 5 and y2 is 1 and R2 is 15 and y1 it is minus 3, whole by 5 plus 15. So let's solve this further. So this is 5 into 15, we'll be getting this as minus 75, and this is 15 into 7, that will be getting as 105, whole by 5 plus 15 will be getting 20, and this is 5 ones 5, and this is 15 into 3 will be getting that as 45, whole by 20. So let's solve this further. So I can get this as 75, that is minus 75 and plus 105 will be getting the value as 30 by 20, and this is 5 minus 45 will be getting the value as minus 40 by 20. So let's solve this further. So here 0 0 can be cancelled, so we are getting 3 by 2, whereas this also 0 0 can be cancelled, and this is 2 1s are 2 2s are. So we are getting this as 3 by 2 comma minus 2 we are getting as the point. So this is the internal center of similitude which we got, where the point we have taken this as px comma y. So this is the internal center of similitude which we got. So this is the figure we could observe for internal center of similitude. So this is the point P, we can say the point P, we can write this as 3 by 2 and this is minus 2. So this is the point which we got, that is P is the point which is 3 by 2 and minus 2. So this is the internal center of similitude which we got. So now even we'll find out the external center of similitude. Okay, so for that I can write here external center of similitude divides C1 C2 in the ratio R1 is to R2 externally. Alright, so what is the first center? That is 7 comma minus 3, and the second center it is minus 15 comma 1, and when we see the radiuses, that is R1 is to R2, which we got 5 and the other one is 15. Alright, so let's do even the external center of similitude. For that I can write here therefore external center of similitude, which the point we can say Q. Alright, Qx comma y, we'll write it as R1x2 minus R2x1 by R1 minus R2, and this is R1y2 minus R2y1 by R1 minus R2. So let's submit these values. So this has x1, this has y1, this is x2, this is y2, and these are the R1, R2 values. So let's submit these values. So R1 it is 5 and x2 it is minus 15 and R2 it is 15 and x1 it is 7 whole by R1 it is 5 and R2 it is 15, whereas when it comes to R1 it is 5 and y2 it is 1 and R2 it is 15 and y1 it is minus 3 whole by this is 5 minus 15. So let's try to solve this further. So when we just multiply 5 into 15, that will be getting as 75. Alright, so let's write these values. That is 5 into 15, that is minus 75, minus 15 into 7 if we multiply, that we were getting as 105 whole by 5 minus 15, which is minus 10, and here this is 5 ones, it was 5, minus into minus plus, so this is 15 into 3, we will be getting that as 45 whole by this is minus 10. So let's write this further. So this I can write it as minus 75 and minus 105, will be getting that as minus 180 by minus 10, and the other point is 5 plus 45, which is 50 by 10. Alright, so 0 0 can be cancelled, so we'll be getting the values minus 18, and this is 0 0 can be cancelled, and this is minus 5. Okay, so this is the external center of similitude which we got. So now they asked us to find out internal center of similitude and also the external center of similitude. So both of them we got it. So the approximate figure, as we discussed earlier, we'll make the figure again for the clarity. So this is an approximate figure as we already discussed. So we'll just have a simple review for clarity. So this is the two circles, this is first circle and second circle which they gave, and they asked us to find out the external internal similitude. So the external similitude which we took it as Q, so the Q value we got it as minus 18 and minus 5, whereas the internal center of similitude which we have taken it as P over here, so the P value we got it as the P point, that is 3 by 2 comma minus 2. So this is the P point which we got over here. So Q and P, both of the points we got, and we got even the 4 tangents. So we could say this is tangent number 1 and this is tangent number 2 and this is tangent number 3 and this is tangent number 4. So these are the 4 tangents which we got for both of these circles. So this is all about this particular question.